Hello, everybody, and welcome to another episode of the Smart Human Podcast. Today, I have the pleasure of chatting with Professor Heather Stapleton, who's an environmental chemist and exposure scientist in the Nicholas School of Environment at Duke University. And also, Dr. Stapleton serves as director of the Duke Environmental Analysis Laboratory. Today, we're talking nonstick, waterproof, and greaseproof chemicals, flame retardant chemicals, drinking water quality, and different types of water filters, and so much more. So stay tuned. Hello, everyone, and welcome to another episode of the Smart Human Podcast. Today, I have the pleasure of chatting with Professor and Dr. Heather Stapleton, who's an environmental chemist and exposure scientist in the Nicholas School of the Environment at Duke University, North Carolina. Her research interests focus on identification of halogenated and organophosphate chemicals in building materials, furnishings, and consumer products, and estimation of human exposure, particularly in vulnerable populations such as pregnant women and children. Among many of her awards, as I went through fastidiously and carefully, in 2008, she won the Outstanding New Environmental Health Scientist Award, the WONS Award, on flame retardants and their effect on thyroid hormone regulation. And also in 2019, she was awarded an NIEHS grant to establish the Duke Environmental Analysis Laboratory, where she leads a team that provides scientists access to cutting-edge tools to characterization of known and unknown chemical contaminants in biological and environmental samples. Currently, she serves as the director for the Duke Superfund Research Center and director of the Duke Environmental Analysis Laboratory, which is part of NIH's Human Health Environmental Analysis Resource. Welcome to the program, and thank you so much for taking the time out of your very busy schedule.
Well, thank you for having me. I appreciate it.
So I just want to begin by saying that I came across some of your studies 10, 12 years ago when I was really just getting into this area. And I loved that you, first of all, it seems so passionate what you were doing at the time. And I guess that was around the WONS time when you won that award on flame retardants. I wanted to get to, number one, where did this all begin? Where did all this passion begin for you? Was it something in your childhood? Was it something you stumbled across in college or grad school? So tell us a little bit about your journey.
Sure. Well, actually, when I was a kid, I really loved the outdoors and I loved the ocean. I was in a landlocked part of upstate New York, and I actually was never able to see the ocean or put my feet in the water till I was 16, and was able to visit Cape Cod. And I just knew at that point that I wanted to go to college to study the environment and to understand the impact of man's activities on the environment. And at that point, I was really interested in marine biology and marine science. But as I went to school, I became more interested in chemistry, and chemistry just clicked in my head. I really enjoyed it and ended up going to grad school to focus on an environmental chemistry, although with an application in marine estuarine settings. But it was actually after I graduated and took a full-time job actually working for the federal government at the National Institutes of Standards and Technology that I became more interested in understanding exposure to people. And particularly when I was pregnant with my first child, I paid a lot more attention to the materials and the products that I brought into my home. And I realized that that was just an understudied area that I thought deserved a lot more attention. And then it just all grew from there. And I felt like it just kind of cascaded into a number of different directions and avenues. So that's a brief synopsis.
It almost begs the question, should there be many more women in research who are studying this area, because they're the ones that are almost more cognizant from an anthropology perspective of nesting. The work that I actually came across back many years ago started off with flame retardants. And I wondered if you could, we're going to get into hopefully a bunch of different topics and maybe end with drinking water, which is my favorite. But I wanted to get your overall picture of the flame retardant world as you knew it when you kind of jumped into that area, and to kind of give us a little background on where this problem started and where you are finding yourself in terms of your research.
Certainly. It actually all started when I was a PhD student at the University of Maryland. There were some publications that were coming out and a few talks that I heard at conferences related to the detection of these emerging contaminants. And at that time, these were the polybrominated diphenyl ethers. They go by an acronym PBDEs. They are brominated aromatic compounds that looked a lot like a persistent chemical. And several studies had shown that the concentrations of these compounds were increasing in archived samples. So if you looked at samples from the 70s, these were low, 80s, they were higher, 90s, they were even higher, suggesting that our exposure was increasing. But at that time, all the attention was on these samples that had been archived and reflected the outdoor environment. So there was archived fish tissues and sediment cores and things like that. And it was actually when I was a postdoc at NIST, and I was helping to develop analytical methods from some of their standard reference materials, that I was given a sample of house dust. And the goal was to actually look at it for lead, but other organic contaminants like phthalates that are used as plasticizers in building materials. But I ended up analyzing it for flame retardants. I'm like, I'm really curious what's in here. And I was shocked at how high the levels were. I mean, they were so high, they were off our calibration curves. We couldn't even quantify them. We had to keep diluting it down to quantify them. And I just remember thinking, well, maybe this makes sense. These chemicals are likely used in the indoor environment, but everyone's focusing on the outdoor environment. And we really need a greater understanding of what we're exposed to indoors, because we all spend our time indoors, right? A lot of people are sitting on their sofas watching TV, and it's likely the sofas had these chemicals in there. We really needed to know more about them if we wanted to have adequate information for our risk assessment.
So you end up looking at dust. You end up finding that there's a lot more that's underneath the cover of dust, not just skin cells. I mean, most of us kind of think, it's like skin cells and maybe some cleaning products or whatever. But your deeper dive shows you phthalates, it shows you flame retardants, it shows you all these other things that you're like, where are they coming from? So with the flame retardant story, I mean, it's a long story, but in brief, it all came out of this desire, I would say this faux desire, as sort of the Chicago Tribune brought to light, that, it was really the tobacco industry pushing to put these chemicals in home furnishings like couches to allow for this 12-second burn time. If you were to drop your cigarette on the couch and it would start a fire, then people could, get out of the home safely with this 12-second burn time. What was the problem with this, as we soon found out, I guess, not so much soon found out, but maybe like 2 decades later, we started to figure out what was the problem with the flame retardants to begin with and that legislation TB 117?
Sure. Well, we have to keep in mind flame retardants are used in a number of applications. I think a lot of what we're talking about today and what we focused on are its application in residential furniture or in furniture in general, which we can talk about. But we have to keep in mind they're used in a lot of other applications that fall under different standards. Some regulated by the U.S. scale, some at global scales, et cetera. But when it came to residential furniture, I became familiar with this standard you're referring to, California Technical Bulletin 117, which was a standard implemented in the 70s when there was concerns about people smoking in bed or on their sofa and falling asleep, and then it leading to the first to ignition that led to a lot of hazardous conditions for sure. But it wasn't always clear to me how much of a benefit it was versus what a risk it was. And I wasn't a fire scientist. And this is where I ended up going to other meetings and engaging with other fire scientists, people that set these rules and regulations, that I learned more about it. And what was also shocking to me at the time was the presence and the pressure from the chemical lobbying group. So even when I was a PhD student and I started giving presentations on there, they were always present in our meetings and were quick to kind of find some kind of negative aspect that they could poke a hole in some of our research. And at one point they would do this repeatedly, and I had an answer, and I knew that what they were saying was wrong, so I could respond to it. But it was quite clear this was a big deal and had larger ramifications than I initially understood. Mm-hmm. And I think it was that growing awareness that led to the Chicago Tribune's coverage of this and uncovering all these kind of deceptive tactics that the lobbyists and the flame retardant companies were using to promote the sales of their product. I mean, this is a $1 billion industry. When you think about it, it's a huge moneymaker for them. So they really didn't want anything that would impact the sales of their items. But yet we had no information on, at that point, the exposure that was occurring, particularly for children from these types of applications of these chemicals, what some of the health hazards were, the toxicity, and just also what happens when they burn. And I thought that was a really important angle. We finally have some data on there. Like if they are present in your furniture and there is a fire, Well, it turns out they generate more smoke and other hazardous chemicals. So those are just as much as a risk as other applications in having flame retardants there. So it was important to have more information on this topic.
So what, and that's, wonderful, because they reversed the law. The TB 117 was reversed in 2013. And so that allowed for manufacturers to voluntarily, mind you, replace those chemicals in their home furnishings. At this stage, have most of the big manufacturers, I think, have been on board. It's been, 10 years now. But is that your experience? Because you used to actually offer people to send in their mattresses and their couch material to actually test in your lab. And I don't even know where I heard about that, but I just found that so fascinating. You could chop off a piece, send it, and find out really how toxic your sleeping environment was, or your home, really.
Yeah, we actually still offer that service if people are interested. We opened that service in 2014. It's accessible via our website. It's just, if you go and probably if you just type in Duke Superfund Foam Project, it should come up. We published several papers reporting on the detection and presence of these hazardous chemicals in furniture, primarily in sofas and then baby products. And a lot of people were interested in knowing whether these chemicals were in their products. And you can't look at it and you can't look at the label and discern whether or not it's present or not. And that's really unfortunate. So we offered up this service. We were lucky to get some funding from the Superfund Research Program to support free testing for the public. We could analyze 50 samples a month, return results to a participant, and let them make an informed decision, maybe to replace it if they had a concern, or put their mind at rest if it wasn't present. And that's still going on. So we've been collecting data since 2014, so 9 years now. We have analyzed, I think it's over 3,000 samples now, and that provides a lot of insight to us to understand how industry has responded to all these changes and responded to the shift in chemical use. Because while the flammability standard was changed, there's also been several states that have passed bills restricting the use of specific flame retardants in products. So it's been a very dynamic change over the past couple of years. And what we've seen is that overall, yes, there's been a decrease in the use of flame retardants in residential furniture that falls under the purview of California Technical Bulletin 117. It went from about 80% detection of these hazardous chemicals to the more recent samples we have, it's less than 10% of the samples that come in now have a flame retardant. But it does seem like sometimes there are a few industries or manufacturers that may be using them. And I've heard from some manufacturers that they're still concerned about liability issues. So they feel that it's important to include them, even though the science, I think, doesn't suggest they're really helping out in the case of a fire. So
Right. I mean, just fire safety. Yeah, I'm sure it's ongoing. And so when you say offer up samples, if you have just your typical mattress with box spring and springs, is that the type of sample you're looking for? Are you looking for polyethylene foam? Thank you. Say that 6 times fast. You're talking about foam from couches, foam. Like, what are you looking for in terms of the appropriate samples and how much?
Our website has some photos of what we're looking for. We are specifically interested in testing polyurethane foam, flexible polyurethane foam. That is the material that's more often treated with chemical flame retardants. Things like polyester batting that might be more present in something like a futon is less likely to be treated with these hazardous chemicals just due to the different materials and how they pass a flammability standard. So specifically polyurethane foam. Now there are some mattresses that do have polyurethane foam. It's important to realize that mattresses fall under a completely different flammability standard. So they don't fall under California Technical Bulletin 117. They fall under a federal standard from the Consumer Product Safety Commission. But we have found some mattresses that also contain flame retardants, and I don't think they've been impacted by this change in California TB 117. So it varies quite a bit, and most people are less inclined to cut into their mattress to test it and send us samples than hopefully a sofa where you have a zipper on the cushion and you can open it up and take a really small marble-sized piece. So we have a lot more data on the use in residential furniture than we do mattresses, but of the data we have in mattresses, it is clear that they have also been used there by some manufacturers and more likely to be found in mattresses that have more polyurethane foam in them, yes.
Would that extend to baby mattresses for cribs? How would that play out?
It would, definitely. And And unfortunately, the polyurethane foam crib mattresses are often cheaper and more economical than the mattresses that have springs in there. So they are common. They're particularly common in daycares and nurseries. So I do worry a little bit about exposure in that regard. We have tested a few baby mattresses and have found some of these halogenated chemicals present. And so I do think there is a need still to understand infants' exposure to these chemicals while they're sleeping on these mattresses.
And car seats that have foam, they're under a different purview, right? They're under Federal Transportation Commission, is that correct?
Yeah, motor vehicle standard. Yes.
Okay, so they have to be in there, those flame retardants, technically, is what the argument is.
It's always the standard that dictates what happens, right? So it's how a company meets a standard that's set out. Now, sometimes they can meet that standard without flame retardants, but sometimes it's the cheaper avenue to add the flame retardants in to meet that standard. We have tested a number of car seats, and based on what we're seeing, and I think we need more data, it does look like the applications are decreasing in car seats. And we've had conversations with several manufacturers where they are taking active steps to remove these chemicals from their products. And so I have hope that there's progress being made with the car seats.
Me too. It's come a long way, and I think a lot of it's come a long way from the work you're doing, actually, because of all the papers you've helped to publish and get into the public. So let's step back for a second for this particular audience who may not be scientists and may not have a strong science background. I just wanted to go back to this concept of halogenated chemicals. Where are they located on my kids' middle school elements table? How does that affect what we use in terms of the halogenated, micronutrients that we use, like iodine? And tell us how that connects into sort of clinical disease and why they're so harmful.
Sure. Well, there's just a general tendency to be concerned about halogenated compounds in man-made chemicals, in part due to a lot of the research that we've gained from pesticide use in the U.S. and more broadly, things like DDT and the use of polychlorinated biphenyls. And what's apparent is that when you have a halogen like bromine, chlorine, sometimes iodine and fluorine, particularly on an aromatic compound, it leads to a lot of stability. So it's less likely that chemical is going to break down. And we also know that sometimes that type of a bond or moiety feature can also lead to greater interactions with some receptors in our body. And you mentioned iodine. That's a great example. Iodine is a halogen. It's essential for the development of thyroid hormones, production of thyroid hormones by our thyroid gland, and for the regulation of a number of our metabolism and catabolism and growth and development. And thyroid hormones are aromatic compounds with iodine on them. And this is one of the reasons why I'm concerned always about aromatic halogenated compounds, is because many of them do interfere with thyroid hormone regulation. We know thyroid cancer incident rates have been on the rise over the past couple of years. Thyroid disease in general is on the rise. It's really not clear what's driving this, and there is a lot of interest in understanding if there's a connection with the use of these halogenated compounds. I definitely think it's feasible, but again, like everything, we need more research, and this is always an area that's really hard to get funding to understand the role of chemical exposures and thyroid risk, cancer risk.
Yeah, I mean, clinically, and again, you're the researcher, I'm the clinician, I see the downstream effects of a lot of these exposures, and I'm seeing so many young people on thyroid medications, no family history of thyroid disease, hypo, Hashimoto's, no history of thyroid cancer, which is generally considered a younger person's disease, and it's all epidemically growing. It's really remarkable. And so I think when people understand that what these chemicals, and correct me if I'm wrong, can do in terms of food washes and flame retardants, and there's a whole bunch of chemicals that are allowable in the food industry too, what they do is they kind of fight for the spaces on the thyroid that hold iodine. And so maybe it's a nutritional component, maybe we're not getting enough iodine from our food, but maybe it's just because we have too much competition with the world that we've created around us. And I agree, there's more research to be done, but there has been a lot of research already done. So, it's just one of those things to consider in terms of changing out couches or furniture, or in terms of food washes, I think that are USDA organic often don't allow for that. Am I correct on that?
Well, organic food shouldn't have any of these pesticides applied to them. But sometimes you can still get residues of legacy compounds on there. And even rinsing with water, unfortunately, doesn't remove a lot. You really do need some of those soaps or detergents or something else to help remove them, or at least let them sit in water for a long
Or
period.
baking soda vinegar can pull some of those off. So that's great to know. And in terms of the brominated versus iodinated versus chloridinate, basically it's that chlorine or iodine or bromine that's attached that's really part of that chemical that's getting into our body to affect it.
That carbon halogen bond, it also has the potential to bind to proteins in our body that circulate the thyroid hormones to specific tissues, to bind with our thyroid nuclear receptors, which are important in activating transcriptional responses. So there's a number of points, I think, along the pathway, the axes, the thyroid axes in which these chemicals can disrupt the process.
Okay, so let's jump in from brominated flame retardants. Let's have more fun. Let's talk about the PFAS chemicals, which have made a lot of news, and we all know about, or at least a lot of people have heard about the movie Dark Waters. That brought a lot of attention to mainstream, to media, and we know about, Robert Billett, who was interviewed actually on this podcast, will be speaking about it as well in a few months. But the idea is that we have a whole different class, not just flame retardants, which are included in the PFAS, but they are used, this one class of chemicals has been used in a variety of other products, cosmetics and popcorn bags that are microwave, and firefighter material, which you said is outside of the home furnishings overhead. So tell me a little bit about, or tell the audience and myself about the PFAS chemicals and what they are.
Sure. PFAS is an acronym for per and polyfluorinated alkyl substances. It's a mouthful, I know. We're really diving into the chemistry today, which I love it. These are another class of compounds. Sometimes they're called forever chemicals because many of them are very persistent. As we were talking about this idea of persistence with that, halogenated compounds, PFAS are another example, because many of these compounds have lots of carbon-fluorine bonds. It's the strongest bond out there, so they're less likely to degrade or break, leading to degradation of these compounds. So there's over, I don't know, depending on which report you see, there's either 5,000 or 10,000 of these compounds out there on the market. They're used primarily as water and grease repellents in a number of applications. So you think about your stain repellent carpets or your furniture. They're used on the inside of food packaging, as you mentioned before. They are found in particularly water repellent mascara and some cosmetics. They're in the turnout gear from firefighters. They're in this, what we call AFFF, aqueous film forming foam, which is used as a flame retardant. So there's lots of different applications out there, and they've been used, I think, since the 1920s or 30s out there. So what's unfortunate, I think, about PFAS is that they're often used in a proprietary manner, and again, a non-disclosed manner. So you can never look at something and know if PFAS are present. And as a chemist and exposure scientist, that is always really frustrating to me. And I'm one of these people that when I go to a store, if I'm buying food, I'm always looking at the ingredients. Or if I'm walking through Lowe's or Home Depot, I'm looking like, what is in this product? I want to know what's in here. And I think sometimes it's not even transparent to the manufacturers because our supply chains have so many steps in the process. So there's a need to know more about where they're coming from, right? If we're going to try to mitigate exposure and risk. Right now, there's a lot of attention on these communities that have contaminated drinking water, which makes sense, obviously, because there's a direct link with high exposure when it's present in your drinking water. There's a lot of attention on certain occupations where there's likely to be high exposure, like the firefighters that you mentioned. And I think it's becoming clear from the large number of epidemiology studies that have been published now that there is more likely to be a causal link between exposure and some of these health outcomes, particularly things like kidney cancer and testicular cancer, and thyroid disease is another area where there's been some links with PFAS exposure. So it's, I think there's a lot of interest. The government's funding a lot of research now on PFAS, so I think that's great, and we'll know more, but I still think there's so many uses of these chemicals we don't know about. For example, there was a paper published just a few months ago from Jennifer Field's group at Oregon State University highlighting the presence of PFAS in indoor paint, in both outdoor and indoor paint, but the indoor paint is what really concerns me because the chemicals they're identifying are more likely to volatilize out of that paint over time, again, leading to more exposure in the indoor environment. And I know when we have analyzed indoor air and dust, we have seen these chemicals, so we know that they're around, but it seems likely that the paints, maybe the carpets, your furniture could also be sources of these compounds. And so this is really important for us to know, again, to make more informed risk management.
So when we buy low VOC or no VOC paint, does that necessarily guarantee you're not going to have the PFAS chemicals that are maybe in there that may volatilize into the air?
There's no guarantee that doesn't include PFAS, no. I mean, they're being added for durability of the paint and for some stain repellent properties of the paint. So you probably want to avoid paint, if possible, that says, particularly if it says stain repellent. I think that's probably more likely to contain PFAS. But again, we're still learning about the use of PFAS in paint right now.
When I think about, I want to say in 2000, maybe, 10, 11, 12, when I was spraying my couch with stain guard because I had 2 young kids spilling stuff all over the couch. I mean, not even involved really in this work. And I remember literally spraying my couch with stain guard material. And we ended up getting rid of it eventually, but couches are expensive. And between flame retardants and now these PFAS that are sort of making their way into everything that you eat and drink, or fast food wrappers, and it's really quite frustrating. Now, there's a different.
Avoid your couch altogether.
well, maybe it'll make you more, exercise more. I don't know, but the idea is that you're almost like a prisoner of your own creation. Not knowing that we're doing this to ourselves until and then you try to do better without going nuts. Tell me a little bit about the long chain versus the short chain PFAS chemicals, because that plays into our conversation. We're going to have a little bit about water and water filters, which I'm dying to get into. But just tell us a little bit about that chemistry, because I know you like the chemistry. So let's teach the audience a little bit about what's been banned, what's not, what are we finding everywhere?
Sure. I'm happy to jump into that. I just the one thing just popped into my head I also just wanted to share is that back in 2018, so I know that seems like a while ago, I remember buying a new car. And when I was buying this new car, the sales representative was really emphatic in trying to sell me this add-on treatment to my car that would lead to stain repellent properties. And he's like, this is going to be great for your car. You really want to have this in there. It's really important. You've got one for the outside. We've got one for the inside. And I said, just because I wanted to see what he said. I'm like, well, show me more information. What is that made of, right? And so they actually had this little video where it came out and it had the little atoms showing a fluorine base to it. It didn't provide the full details on the chemical structure, but it was clear it was fluorine based. And I just remember my husband was sitting next to me and he's going, oh, here we go. And I started saying,
I have one of those. Yeah.
I just started saying, nope, I really don't want this. And he really kept pushing it. And you're like, oh, you want this? And I'm like, no, this is a fluorine-based chemistry. I personally think this is really bad. We should particularly not be spraying them in a closed environment like a car, particularly in North Carolina in the summer when they're going to volatilize off and you're going to lead to all these high exposures. I said, and I started asking how they apply this. And they sometimes they just spray it on and some of that just goes down the drain pipe. And it really just, I think, concerns me about the impact to people working there and applying this, but also what's happening to all that waste that's going into the drain. So I think there's a lot of applications we need to know more about. But getting back to your question about
I was going to say, walking through this world with kind of chemical colored glasses where you're kind of seeing too much that too much. It can be exasperating. So, we'll get into that too. Well, I'm going to ask you about that in terms of the future, but tell me again, I cut you off. So short chain, long chain, go for it.
Sure. Short chain versus long chain just refers to the number of carbons that are linked together in a long chain. So there's a tendency to think that based on the data we have, that the long chains are more persistent, potentially more hazardous, more likely to accumulate in our bodies, stick around for longer periods of time. And so with that data and that in mind, industry did try to shift course a little bit and start producing short chain PFAS. Short versus long, it kind of depends on the chemical class, but usually the where it splits is about 7 carbon atoms long. So I think it's still unclear about how toxic some of these short chain molecules are, and I think we need more data there. They do seem to have different fate in the environment, be a little more soluble, less likely to stick around in our body. But if there's still chronic exposure to them every day, that still presents a risk and a hazard, and we need to know more about them. And with that in mind, I think we also now it's quite clear that there is a 6-carbon perfluorosulfonic acid that goes by the acronym PFHXS, and then there's an 8-carbon that goes by PFOS, PFOS. Well, it turns out the C6 has a longer half-life in our body than the C8 does. And so why is that? We have a lot of good theories and things to follow up on, but we don't know. So I think there's still a lot of ambiguity in this thought that short chains are going to be better. I think they'll have be less persistent in our bodies, hopefully overall for a large number of them. But there's still a lot of questions, I think.
And the PFAS chemical is very similar to some of these other kind of endocrine disrupting chemicals in the sense that they have the ability to affect the endocrine system. PFAS chemicals, I'm not sure which ones, but in general have the ability also to affect the immune system in terms of decreasing our body's ability to mount an immune response when vaccinated, which I think is a very important understanding of whether or not vaccines take hold and have effect, which is obviously why they're designed. Do you have comments about that in terms of where this goes with COVID-19 and certainly future pandemics, which we're likely to have?
Certainly. I know there's a lot of ongoing studies right now that are trying to answer this question specifically in light of the COVID pandemic. So I'm hoping there'll be some more data coming out soon. There are certainly several studies that have shown that people of higher PFAS exposure have lower, reduced amount of antibodies for some of these, and particularly lower responses to some of the vaccines that they were given as children. So I think we have to wait for the data, and it's not really my area of expertise, so I'm probably not going to comment too much on that one. Save it for some of the other experts out there.
Yeah, no, I think it's all very interesting because it's kind of like, the horse left the stable. Now I guess is a good time to comment. I mean, we have such a regrettable substitution list that goes beyond just BPA or bisphenol A that was, banned just in baby bottles and BPS, SIP and all that. Now we have certainly many generations of flame retardants since Arlene Bloom's research and getting it out of pajamas, a certain class. Now we have this new iteration of PFAS chemicals. Every time they're fought and won against, if that happens, there's a new set that hasn't been cleared for safety or toxicity, especially in vulnerable populations. So how does that make you feel as someone who's so dug in deep in this entrenched world of chemicals?
Yeah. I call that the chemical conveyor belt. Some people call it whack-a-mole, right?
Yeah.
So you get one, you understand one, and then you switch to another one. And sometimes I think this is part of the chemical industry's R&D, right? They always have a backup plan because they probably are anticipating or have a thought that one of these could be restricted from use, because usually they're just changing the chemistry very slightly. It's like a pivot or a change in one atom. In particular, I remember it was around 2012, I think it was, we were conducting research on this one flame retardant that's been heavily used in electronics, particularly the casings of televisions, and it goes by the acronym or the name DECA-BDE, which stands for decabromo-diphenyl ether. It's one of the PBDE commercial mixtures. It was heavily used in the casings of electronics, and then that was phased out. And the industry's response to that was to actually produce a molecule that was basically the same thing. They just removed an oxygen and put an extra carbon into the middle of the linkers between the two aromatic rings. So they had decabromo-diphenyl ethane. And now that's being used today as a replacement for it. And it seems to have a very similar fate and behavior to the BDE 209. So we're just going to continue to play this game with the industry unless we can push for a change in chemical management. They're thinking about these things ahead of time, and it really requires change at the source, or else this is just going to persist. In some ways, it keeps our group very busy. It becomes almost like a forensic investigation, like our own version of CSI here. We're trying to figure out what they're using as a replacement. And I have to admit, as a scientist, I find it kind of cool to kind of slew these things out. But at the same time, I'd rather have them not be there in the first place. So
I was just going to ask if your lab has a bar. I mean, obviously organic wine and beer, but I'm just, curious because, I sometimes just, go into my kitchen here and just want to have a drink. That's all I want is a drink, Yeah, I know it's really kind of interesting, but frustrating. I think, if you love the science, if you're a science geek, it's fun, but it's not fun if it has real life consequences. And I think that's the problem I contend with, you contend with, especially if you have a family, It's just one of those things. So what are the current MCLs that's been changing? MCLs means maximum contaminant concentration, maximum contamination limit by the EPA, Environmental Protection Agency in the United States. It used to be 70 a few years back in terms of the PFOA and the PFAS versions of the PFAS chemicals. Can you tell me how that's kind of moving in at least a positive direction for drinking water? And we'll get into that.
Yeah, certainly. So as we were saying before, drinking water is the big concern right now with PFAS. So there are several states that have passed regulatory enforceable MCLs or maximum contaminant levels. Right now, the EPA is in the process of proposing and establishing MCLs. They're not quite there yet. I was actually hoping, most of us were anticipating a release of that in December before the end of 2022. It didn't happen, but we anticipate it'll be very soon. Prior to that, there was a health advisory, which is a recommended goal to protect human health, but non-enforceable. And that was 70 parts per trillion, which is a nanogram per liter for PFAS and PFOA, or the sum of those two.
Wait, can I stop you for a second? Parts per trillion. Can you give this audience a real life example of what that means? Estimate. Isn't it like one drop in like 20 Olympic-sized swimming pools or something?
It's definitely, yes, like a drop in an Olympic-sized swimming pool. I heard somebody use a little sugar packet before, but I think a drop would be more accurate for a parts per trillion instead of a parts per billion. Yes.
Okay.
It's
insane. So that's the health alert was on the 70 parts per
70 parts per trillion. Right.
And that's an exposure over a day or one exposure, or how does that break down?
Yes, thank you. That is nanograms per liter. That was the concentration in drinking water, assuming there's an adult ingests so much water per day. So it wasn't based on your body weight or how much you consumed. It was in just the water concentration with assumptions of how much water people drink per day, like a liter and a half. But it was reduced to a very, very low level in, June of last year, June of 2022, where it was reduced down to 0.004 parts per trillium or nanograms per liter, which is actually lower than we can actually measure today with the current analytical instrumentation. So the environmental chemist in me was a little upset by this, because then you can't really tell people if the water is safe or not, because you can't measure that low. At the same time, I understand that the data that they evaluated to make that decision was suggesting really there's no safe level of exposure for these compounds, and we have to be concerned. And I get that. And I think when they actually finally release the MCLs, hopefully here very shortly in the next few weeks, it's going to be somewhere between 70 and 0.004, and I would guess it's probably going to be somewhere around 10. Everyone's anxiously awaiting those results, and I think that'll help drinking water utilities in particular understand how they can manage this contaminant a little bit better, or I hope so.
But even in the water, I believe there's 160,000 wastewater treatment plants in the U.S., more or less. And so this would basically be a referendum on what they're actually entirely looking at, not just the 91 chemicals under the Safe Drinking Water Act, which is ridiculously low, but it's going to add to that list. And then they would have to sort of make sure they remediate if it comes up in their particular location.
It'll require them to monitor the levels on a certain frequent basis, and then take corrective action or take some action if it falls higher than those levels, for sure.
But that's only for that's only wastewater treatment plants. So what happens to the fresh water with all the contamination of the fresh water, the wells that we deal with? Can you make a comment as to what happens to those folks that drink and rely? 20% of the U.S. population relies on well water.
Sure. And just to correct, it's not wastewater. That's for drinking water utilities.
Okay.
That regulation. And so, a lot of people are in wells. So they would have to be testing that on their own if they wanted to get information on there. I will say it really depends on where you are. I know down near the Chemours facility in Fayetteville, North Carolina, there's been some wells that have been impacted with pretty high levels because they're in close proximity to that manufacturing site. Here near Duke's campus, we've tested a number of private wells, and they're very, very low. They're often lower than the surface water that's used for more municipal water supplies. So I think it really depends on where you are, but I would be hopeful that more people would be less likely to have impacted private wells, but I know it's going to really vary depending on where you live, unfortunately. But people can take steps in their home. They can add on different filters that can help out, as I know you were alluding to that study we did with Detlef Kanapi at NC State. So
this is the one. This is the winner, highlighted and annotated. I would love you to start talking about that one, because really it's kind of your natural progression into sort of many of these chemicals into sort of getting down more towards the source of where it gets into human bodies. I think that's great. So please tell me about this study that you did in 2020, I believe it was, that it was published.
Yes.
Go ahead. Tell me it's a wonderful study.
Well, I guess I can back up and try to talk about how we even got into that study.
Sure.
I actually ended up testing my own drinking water for PFAS because I was trying to compare it to what I thought would be a contaminated sample. And so I wanted to have a contaminated, but I wanted to have one that I thought would be really, really low. So I took a drinking water sample from my own home and brought it into the lab thinking it would be low and this other one would be high. And what I got back was the exact opposite. And I was shocked. And I remember thinking I must have done something wrong. So I contacted my colleague at the EPA, Dr. Mark Striner, had done this for a while. He's like, no, you must have done something wrong. Maybe we contaminated it. He's like, let me come over. I'll grab a sample and I'll analyze it. So he comes and he grabs a sample and he gets the same thing, which made me feel better about my lab. But at the same time, I was still concerned about. And kind of digging into this deeper and talking to Detlef Knappe at NC State University, it became apparent that the drinking water source, which here for my home was Jordan Lake, was contaminated likely from the Haw River because PFAS had been identified at fairly high levels in the Haw River. It empties into Jordan Lake, and we thought that was the reason why. So we ended up just kind of doing more testing and more sampling of Jordan Lake and some other areas to understand the relative differences in PFAS. And we're kind of shocked at how high they were in Jordan Lake and the Haw River. And then we wanted to ask the question, well, what about these different filters that are out there on the market? Right. Will this be a recommendation, an advantage to having one of these homes to reduce the PFAS burden? In particular, because what we were seeing are some of these short chain PFAS, these newer ones on the market. Right. And while there was data suggesting the long chains would be removed effectively, like by something like a Brita water filter, I wasn't so sure about the short chains because they are more soluble. And I was worried they were more likely to go through the filters. So we conducted a study and we asked people to participate. So it was voluntary. If they would allow us to come to their home, we would bring our sampling equipment to their home. We wanted to collect the raw water coming in through the faucet, but then also water that went through whatever filter they had in the home. You know, some people had an attachment right on their faucet. Some people were using the filter on the refrigerator. And then some people had these really advanced systems that were underneath their sink, like a 2-stage filter or a reverse osmosis system. And a few people had whole house water filters. They were really anxious for us to test that. Right. And so, it was a good number of samples. Certainly, it's not all inclusive, and it's really reflective here of North Carolina. But we did find that point of use drinking water filters definitely help remove PFAS, but there's quite a bit of variability in the reduction of PFAS that we observed. Some remove them completely, particularly the reverse osmosis units, which is probably not too much of a surprise. It's the more expensive filtration system out there. It uses a membrane technology, so only things that are really, really small are going to get through. Whereas the granular activated carbon filters like your Brita filter, or what's common on a refrigerator, removed some, but not all, and some removed hardly any at all. And this could be differences in manufacturers and the type of carbon that was in there, but also probably relates to what volume of water has gone through that filter before it gets saturated, because a lot of these can get saturated and they just stop working, right? So there's this recommendation to change your cartridge on a certain frequency, but it's not based on time. It's based on the volume of water that goes through, and it's also based on the composition of that water, right? Because if you have more dissolved organic carbon, it's going to saturate that more quickly. And so a lot of these short chains, PFAS, were going right through the Brita filter. Some of the Brita filters, and we found a few where the filtered water had higher concentrations than the raw water coming in because of this saturation effect. So I think that was eye-opening to not only us, but some of the participants when we would share these results with them. So we learned a lot from that study. We tried to make recommendations, and we know not everyone can afford a reverse osmosis filter. I mean, that's really, and I get that. You don't need a whole house filter. Under the sink works just fine. But if you can't afford one of those, just even a Brita filter will help, but just change those cartridges frequently, as frequently as you can.
That's great information. I have to tell you, this is what I stand on a soapbox saying, that we should all be filtering our water no matter what, if we can. Because, but I have found that even this is obviously not the point of your study. Your study was just to find the science on this information, but I wanted to just kind of parlay into recommendations if we can. The carbon filters varied dramatically, you said, in terms of whether it's Brita or Zero Water, and there's like so many out there. Amazon makes, I think, their own. I mean, there's just so many activated carbon block filters where you drop it in. Those can run really quite expensive for the cartridges.
Mm-hmm.
The reverse osmosis water filters that are under your sink that are vetted and certified, because there's a lot variability there too, a little bit in terms of certification and quality, but they're now like $275. And for a plumber who doesn't have someone handy around the house to put it in, that's about $130 to $150 to put it in 1 hour. It doesn't take more than an hour. People think it's complicated. Plumbers try to make you believe it's complicated, but it's not. And so, the $500 or so up front is really what you need for almost a year and a half, because by then the water pressure drops and you replace your cartridges for about $30 to $40. So think of it more like an upfront cost that actually probably evens out or saves you more money than even bottled water or replacement cartridges for carbon blocks. So that's just my take on it, having watched the same situation as you and tested my own water and tested the reverse osmosis water compared to my tap water to see if I'm actually getting a good RO filter. So I think when you go down that rabbit hole, which is a little on the cray side sometimes if you think about it, but it's just the most important by volume in what we put into our bodies, into our families and our pets and all that stuff.
So agree.
Yeah. So I kind of think that was one of the most important studies I've seen in a really long time, especially for the work I do. And did you have, how many different reverse osmosis I was curious to know about even the reverse osmosis, which you chose, how you chose them, and what your thoughts are with the variability within reverse osmosis.
Well, really, it was who responded to our flyers and wanted to be part of the study. So that's how we ended up with the types of filters that were included in that study. So really, it was just based on the randomization of who responded. I think we had 11 reverse osmosis. They were all different units, but I think all of them did a really good job of removing PFAS. And I think what's also great about reverse osmosis is it works on a large range of compounds. It's not just PFAS. It's going to do a great job of other things, particularly for other things we might not even be aware of, right? If nobody's looking for it, we might not know it's there. There could be other contaminants in there that are not monitored. You mentioned already the 91 through the Safe Drinking Water Act. And this is my concern too about just environmental health issues moving forward, is that we're continually relying on surface waters. We have more urbanizations, right? More fires, more everything. It's just going to lead to higher contamination of our drinking water. And it's going to be hard for us to catch up and monitor it well enough to understand the contaminants that are there. So I think filtering is definitely important. If you can afford reverse osmosis, I think it's the best way to go because it's going to be more inclusive of contaminants. But I certainly recognize, and I'm frustrated by the fact that it is so expensive. So again, anything helps.
I think communities like Flint, Michigan, and Newark, New Jersey, and all the ones that make the news about lead. And other contaminants, chromium-6 with Aaron Brockovich, all of those type of contaminants, they vary, they're, on and off in the news. But I almost feel like they should be subsidized, like states should subsidize RO filters and stop with the plastic water bottles, which contribute to a whole bunch of problems. Just subsidize these and give everyone, I feel like, a sense of dignity in the sense that you need your home to be the source of your water and just give them the opportunity to do that. I don't know if you have thoughts on that, but that's kind of what I've seen throughout the years of these news stories,
I definitely would love to see that, at least in the impacted communities that have this water contamination, right? It's really frustrating to see that these communities that are really upset, and rightly so, and have no avenue to buy these better water filtration systems, right? They're paying taxes to get this clean water supply and are not getting it. And there's just slow response often in these communities to do anything about it. I have heard a lot of pushback from people about moving to reverse osmosis because, right, it's not 100% efficient in the water use. You're actually just, end up concentrating the PFAS into your permeate stream that goes down the waste, right, which is how they operate, and I get that. You are removing some of the essential elements that are in there. It doesn't make it caustic. A lot of these reverse osmosis units put it back in there. I've heard people be all concerned about removing fluoride by the RO systems, and I'm not concerned about that as well. So I think we just need to make sure we're evaluating all these things and not rushing to judgments, because I think today's reverse osmosis units don't have those issues. I think they're good. They're going to work for all of us. I have one in my home. I love it. I think I think it's very important.
Yeah, I agree. And in terms of getting fluoride out, that would be a blessing, not a crime, because we know that's a fluorinated chemical as well. So we don't need to go on that, down that rabbit hole. But yeah, I do think it's something people should consider moving forward. And the other thing is it removes microbes and it removes viruses. So the idea that it takes the baby with the bathwater, that kind of like cleans everything and scrubs it, that's actually a good thing. You can always get your minerals clinically. I tell my patient, you just have a salad with your RO water, or have some green leafy vegetables, organic if you can find it, because that's where you're going to get most of your minerals and micronutrients. You don't need it from your water. In fact, it's very little when it comes from the tap or even groundwater. So it just makes sense to clear everything off and get clean water into your system. So tell me a little bit about your new research. I saw some of your articles on your site, of things that you've recently published and things that you're working on, things like dog tags that have sort of, and silicone wristbands that sort of collect the environmental exposures. Tell us a little bit about some of your newer the research you're excited about with your lab.
Yeah, sure. So for a long time, we focused on the flame retardants, and we've been doing a lot with PFAS. But I think what's important to our research group, and I think others, is that we have to understand the mixtures of chemicals that we're exposed to, right? We're exposed to thousands of different chemicals, man-made chemicals, right? Not just natural ones, every day. And we don't really have a good idea of how they interact with each other and what kind of a risk that presents, right? Because most of our research has been focused on one chemical at a time or one class of chemicals, but as I said, there's thousands out there that we're exposed to. And sometimes these studies are hard to do because, maybe you want to collect a blood sample and it's hard to get blood from everyone, particularly small children. There's urine, but some things you can't detect in urine, or you don't know if it's metabolized to something else. So we've been using these wearable samplers that you talked about. These are silicone wristbands. I have a couple right here I can put on. These are just regular silicone wristbands, kind of like the Live Strong bands.
My 13-year-old has 10 of them up his arm. I bet they're not really the good ones. They're actually the toxic ones, but that's a whole nother story for another day.
Oh, well, these, are super cheap. What's nice about them is that they have properties that are kind of similar to our skin, right? So chemicals that are in our ambient environment, in the air, or particles in the air, or maybe even our clothing, stick to this, and they don't come off very well. So even if you take a shower, they're not really coming off. So if you wear this for a week, the data suggests that what we measure on this after that week is a good measure of your average integrated exposure to those chemicals over that time period. So I equate it to something like a radiation badge that is monitoring your exposure to radiation while you're wearing it. We like to think that these are doing the same thing for organic contaminants in our ambient environment. And what's nice about them is that, this collects so much that we can just take a really small piece, like about an inch, and we can analyze that, and we see thousands of chemicals on there, and we're measuring over 150 different chemicals on there in parts per billion ranges. And we've found that they measure really well, or they predict really well what gets into your body. So we like to hope that we can use these moving forward as almost like a monitoring system that will help provide insight into these mixtures of chemicals that we're exposed to, because what we need to know is what we need to understand is how our exposures to these mixtures change over our life course if we really want to understand risks for chronic disease, right, like cancer and type 2 diabetes and heart disease. And I have hope, or I know I'm a little biased, but I have hope that this can provide more information to look at exposures over time in particular, as I said, like a radiation badge. And so we're using these with small kids. We're using these with pregnant women. We're working with firefighters here in Durham County, and they're wearing them to understand their exposures when they respond to a fire. I think they have a lot of application, and we're really excited about using this to advance our understanding of exposures, again, with the goal of providing more insight to manage risk, but then also thinking about mitigation strategies or ways we can reduce our exposure. So
and less invasive, right? Right. No more blood draws, no more urine samples, no more IRB, requirements in terms of, laws and regs for testing humans. But I think that's really remarkable. And is the goal obviously would be, as you mentioned, a variety of things, but also to get people to make change. I mean, if you're talking about the actual people wearing the bands instead of just sort of the research side, the goal is to really encourage people to make really simpler changes to their environment that they can control, not the things they can't, but the things they can control.
Right.
That's
right? Or if
fascinating.
they have questions about if they are exposed to something or not, maybe this will help us, right? What's nice about these is like we can mail these back and forth to people. They're pretty stable at room temperature. It's not like you have to take a person and find a phlebotomist to do a blood draw, right? We can just mail these back and forth. And that just increases the ease of supporting large scale research in environmental health overall. You can mail them across to different countries, right? So right now there's always concerns about shipping blood or urine back and forth between different countries. It's not an issue with the wristband.
Is that open to your lab as well? Tell us if there's opportunities for our audience to get involved. I mean, if you're looking for, people to get involved, I have a feeling that the selection bias on people listening to this topic are going to be pretty high interest.
That's one of my dream studies. Unfortunately, we're not there yet. I would love to have that ability to send them out to people all over so we could look at differences based on where you live, the time of year, what type of
zip
house
code. Yeah.
Yeah. Right now we have a few specific targeted studies that are ongoing. And I know you mentioned the one with the dogs. We are collaborating with folks at the North Carolina State Veterinary School. There's a growing interest in using companion animals to understand disease risks later in life, like cancer. Unfortunately, dogs in particular are coming down with cancers or being diagnosed with cancers that are very similar to humans. But because of their compressed lifespan, we might have the ability to understand the role of the environment in our genetics and disease risks by focusing on the dog as a model, right? Because there's a time aspect to this, the development of the disease, the exposure, the latency period, in terms of how this manifests. So maybe by focusing on dogs, it can provide us more insight into what these risk factors are. So we do have several studies going on with dogs, which is great. It's always fun. We have these little tags that we put together, and they go on the collar of the dog, and they sit there, and they wear them for a week. And what was interesting, and maybe not too shocking, is that when we had an owner wear a wristband and the dog wear one, their exposures were so similar. I mean, very, very similar, which is what we'd expect because most of our exposures are in the indoor environment. But really,
did they start to look alike as you did that? So not only do their exposures match, but they start to look like each other. No, I just saw a Facebook post for that. But no, I think it's fascinating. I would love to get involved myself because I have a dog, and God knows I would love to see what we're both getting into. But that's actually really, really cool. And it just goes to show you all the different ways we can now kind of, lift the lid and, look under the hood and see where we're all, getting exposed. How about your nail? You did a study years back on nail salons and phthalates. I think people don't know how much we get occupationally into our system. I thought that was something worth mentioning.
Yeah, that was several years ago. It was also actually on flame retardants. We've been monitoring this one type of flame retardant in urine of adults, and we saw that females had higher levels than males. And one of my colleagues was doing research on it and said, hey, there's this report that it could be used in nail polish. And I was like, nail polish? That seems really odd. Well, it turns out this chemical is used not only as a flame retardant, but also as a plasticizer. So it changes the property of the fluids or the polymers it's in. And lo and behold, it was being used in nail polish, some, not all, as this role of a plasticizer. And so we actually ended up buying, I think, about a dozen different brands of nail polish. And we did find it in there. We could measure it. And then I had a great master's student that was really interested in this. So she ran an experiment where she had people paint their nails, and we took urine samples before and after, and you could clearly see this increase in this chemical in the participants' urine after applying this nail polish. And so it was really quite fascinating and eye-opening. And what was unfortunate is even though most nail polishes are labeled, we found it in a few bottles that didn't have it on the label. Some of them had it as an ingredient on the label, but others did not. And so that might reflect the fact that these companies might change their formulations quickly and forget to change the label on their product.
Does your lab work with kind of consumer activism groups like Environmental Working Group directly? I know you and I were involved because we got some samples from a local pediatrician in the Princeton area that helped, I think, inform some of the urinary exposures in children. But in general, do you have a hard time not only connecting with clinicians and also with advocacy groups like EWG? I mean, where do you take your work to get it out there?
Sure. I mean, right now, a lot of our funding comes from the federal government, so that keeps us pretty busy. But we do try to support research where, we think it's really important to have this data or have this understanding. And some of that's come through collaborations with nonprofits and other consulting groups. We have worked with the Environmental Working Group before. We're currently working with Arlene Bloom at the Green Science Policy Institute to look at exposures in cars now. And then I do try to collaborate quite often with physicians when possible. And we have a great medical center here at Duke. And that's one thing I'm always trying to push for are stronger bridges between my department and the School of Medicine. I think it's just really important for the future of environmental health and human health researches overall. I would love to see more MDs get training in environmental health when they go through medical school, but I know that doesn't really happen a lot right now. I understand there's concerns about how much they can fit into the curriculum, but I hope we can make that change moving forward because I think it's just critical. It's the MDs seeing these patients every day. There might be things they can screen for or look for that can help because, right, we all know early diagnosis is so important. Right. So I'm hopeful we can make these change and work more closely with physicians moving forward. And that's something I really push for.
I love hearing that from you because I feel like no one listens. I offered a curriculum on environmental health to 3 medical schools and they didn't want it. The deans did not want it. I said, it's free. Just take it. I swear it's vetted. It's real. I didn't make it up. And they're like, nope, we don't have any room. We just teach diagnosis and pharma or therapy, diagnosis. So it's really frustrating. But I think things like this are in the work you're doing and connecting with Duke and getting those students to listen, I think is fabulous if you can do it. I guess we are running out of time. I swear I could talk to you all day. Tell me, number one, are you hopeful for the future?
Oh, yes, I am hopeful for the future. And, and I'm excited about the direction of a lot of research programs, right? I just don't know how long it's going to take, but I think we're moving in the right direction for sure.
And what would you want to say is like your one wish? I mean, like you did say about the education and you wish it would get more sort of the grassroots and, the clinical world. I mean, what do you as a mom and a researcher and a human being who's been infiltrated with these chemicals, I guess, is kind of a big ask. But I mean, do you have any real thoughts about how this would go from a regulatory standpoint so we can stop the source? I don't know.
The one point that I always make that I push for, I want more transparency in the supply chain and more transparency in chemical use in products. When we did this study on baby products, back in 2011, I just thought it was just tragic that someone could have a cancer-causing chemical in their child's mattress and this baby could be sleeping on it and they would have no way of knowing that. They can't even call the supplier or the manufacturer because often they don't know, right? Unless we bring that into the laboratory and use mass spectrometry, we cannot determine whether these chemicals are present. And I personally think that we should be changing our chemical management plan through TSCA, the Toxic Substances Control Agency Act, to provide more requirements for transparency in chemical use in some products, particularly if it's a product that a child comes into contact with on a chronic basis or a person comes into contact with. We can't make the assumption that it's only a concern if we inhale it or we ingest it. There's a lot of studies now showing the importance of dermal absorption and transfer and exposure through other pathways. We need more transparency. So that's what I push for.
I love it. I think it's great. And so how do people reach you? I know we're going to have links, by the way. I'm going to have Green Science Policy in there about choosing couches. I'm assuming you're on board with that, and some other resources, maybe for drinking water. I'm going to throw those on. And you can send me some of your Duke research and lab. But can people, in order to reach out to you, I mean, I'm not even sure how they would reach out to you and why specifically, but maybe there's some, kind of budding scientist out there who needs to reach out to you, but you're on the Duke website for your lab?
I am, yeah. And I can send you links to my research webpage, and my email is really easy. It's just my name, heather.stapleton@duke.edu. I don't have any of the fancy social media up and running because I feel like I don't even have enough time to do everything I'd like to do, but I can be reached over email. Mm-hmm.
I really appreciate you taking the time to do this. I know you're off to another meeting, but really, you have been someone I wanted to talk to for at least a decade, and I'm really excited to have finally gotten the chance to talk with you and all your amazing work that you're doing to contribute to environmental health work and research. Thank you again, and keep doing what you're doing. And I myself am incredibly proud to have been a part of this hour with you. So thank you.
Well, thank you. Thank you for having me. It was a pleasure.